introduce a little bit about our project, which is electric fan. Electric fans are used for cooling in homes, offices, and other free space to stabilize the temperature. Now, I will read the introduction on enhancing the cooling efficiency of an electric fan. This is a study of rotational motion and thermophysics. This project explores how to improve the cooling performance of an electric fan using physics concepts such as rotational motion and thermophysics. By analyzing how changes in blade design and fan speed affect airflow and temperature regulation, the study aims to find more efficient ways to enhance cooling. The goal is to suggest a practical improvement to fan design based on experimental data and theoretical analysis.
The key need we're addressing is the inefficient cooling performance of standard electric fans. A lot of existing fans just don't do a good enough job. They fail to circulate air properly or maintain a comfortable temperature, especially in enclosed or poorly ventilated spaces. This can lead to discomfort, heat stress, and even health risks in extreme conditions. So, our solution focuses on improving airflow and energy efficiency to meet this critical need. Now, let's take a closer look at exactly whose need we're addressing with this project. First, residential consumers living in hot climates are a major group. Many of them have little to no access to air conditioning, and energy efficient fans could be a game changer for their comfort and health. Next, companies like Dyson or Panasonic, who already manufacture fans, are always seeking innovation. Our solution could be exactly what they need to improve their products and stay ahead in the market. Lastly, we're also thinking about emergency shelters. These places often rely on generators or solar system during crisis, and in such situation, energy cooling is not just helpful, it's vital for survival and well-being. So, our solution doesn't just serve one group, it has the potential to benefit a wide range of people and organizations.
So next, we go to the how often do people experience this problem and when. People mostly experience inadequate cooling when temperature of ambient is high. So fans can blow hot air onto the body and potentially increasing heat rather than cooling. Next, people that live in a hot and arid climates like deserts also often to experience these things because the heat is natural hot. So that's why it is. This need happens when in the house at summers, during afternoon and evening. Sometimes it can be at night. Besides that, conditions in school, university or offices if there is no air conditioning. Last, hospital or data center located in local heat accumulation areas. Furthermore, we go to the how big is the problem for the consumers. So, the problem of inefficient fan cooling is significant and widespread. We must not underestimate this issue. It has major implications for different types of users, especially in hot and humid regions. So first, negative impact on health and causes discomfort to consumers, such as sleep disturbances. So when the heat is so high, it can disturb our sleep. So it can affect overall well-being, mood, and also daily performance. And also, prolonged exposure to heat without effective cooling can lead to heat stress, dehydration, and even heart stroke, especially among vulnerable populations such as the elderly and people with chronic illnesses. After that, energy consumption and waste of course. Fans with lack of design often consume more energy for cooling, which increases electricity bills. And last, reduced productivity in work or school environment. So we take for school. In schools, students find it difficult to focus or stay alert during lessons in poorly ventilated classrooms. So it can affecting their learning outcomes.
What will happen if the need is not met? First of all, if this problem is not solved, several serious consequences will happen, not just to users, but also to companies and even the environment. Firstly, users in hot and humid regions will continue to suffer from discomfort. Standard fans with airflow won't be enough to cool the room properly. This can lead to sleepless nights, fatigue during the day, and even health issues such as heat exhaustion, especially for children and people with medical conditions. Secondly, because the fan doesn't cool efficiently, people will use air conditioners. But air conditioners use a lot more electricity. This leads to higher electricity bills and, more importantly, increase the amount of carbon emissions. Over time, this contributes to environmental problems like global warming. Lastly, in sensitive places like hospitals or server room, poor airflow can cause real danger. Overheating in a server room can damage equipment. In a hospital, unstable room temperature can affect both patient safety and medical device at risk. This why improving fan efficiently using principle of physics like rotational motion is not just helpful, it's necessary. What is our unique approach to meeting this need? Our unique approach focuses on redesigning the fan using physics principles instead of just increasing the power or size of the motor like most standard fans. We look deeply into this concept of rotational motion. In physics, rotational motion tells us that the faster an object spins and the larger the radius. So, when we apply to fan blades, this means if we can optimize the angle, shape, and rotation of the blades, we can create stronger airflow without using more electricity. Secondly, we also modified the blade geometry, including the pitch. This helps push more air forward with each rotation. By increasing the angular velocity, we also increase the speed of air coming off the tips of the fan. In addition, we added airflow guides that help direct the air into different parts of the room more efficiently. Not just straight ahead, this improves the cooling distribution in a closed space. Lastly, we also consider the materials used. Lighter materials reduce the drag and load on the motor, allowing the fan to spin faster with less energy. This makes the entire design more energy and quieter. Instead of solving the problem by adding more power, we are solving it smarter using science. With better design based on rotational motion and thermal flow, we help users cool down faster with less electricity and more comfortable experience.
Okay, so let's talk about the core of our solution. First, we are modifying the blade geometry, including pitch, curvature, and surface area to increase angular velocity and improve airflow efficiency. Next, we are using materials and structures that help reduce drag and minimize heat buildup, ensuring better performance over time. We also test the fan's ability to reach thermal equilibrium faster in a closed environment, so the space cools down more effectively. And finally, we integrate passive airflow guides to direct circulation exactly where it's needed most. In case we face any technical issues, there are several key areas we are ready to address. Firstly, we focus on accurately modeling airflow patterns and temperature changes. Secondly, we aim to balance increased airflow with minimal noise and vibrations. Next, we make sure that any modification will not raise manufacturing costs excessively. Lastly, we will validate all improvements across different room sizes and climates.
In conclusion, inefficient cooling from standard fan is a daily problem in hot, poorly ventilated environments, leading to discomfort, health risks, and energy waste. Our solution tackles this by redesigning fan airflow using smarter blade geometry and passive circulation guides to improve efficiency without raising energy use. This approach offers better comfort for users and a competitive edge for manufacturers seeking eco-friendly performance.